Dear students, now we take up division operation on floating point numbers. So here are the steps. Check for zeros, initialize the registers and evaluate the signs, align the dividend, subtract the exponent and divide the mantissa. So when we divide two numbers which are given in form of mantissa and exponent, then exponents are subtracted and mantissa is divided. So here you see the flow chart, the divisor in BR register and dividend in AC register. First of all, we check BR register. If it is 0, that means divisor is 0, then this is an error, divide by 0 error. So it ends here. But if BR is not 0 and AC is 0, that means dividend is 0. In that case, result will be 0. So we store in QR 0 and the process ends. If both the operands are not 0, then we come to this point where we first decide the sign of the quotient, that is XORing the sign bit of multiplicand and dividend and divisor, and then we put Q is equals to 0, that means quotient is initially 0. Now sequence counter is initial value is equals to n, that is number of bits in the divisor. Then you come here and see that we are taking EA equals to EA minus B, that is A plus B bar plus 1, that 2's complement of B is added to A, that is equivalent to subtraction. Why we are doing this? We are doing this just to check whether A is less than B or greater than B. That concept we have already studied many a times. So if it is 0, then A is less than B. In that case, we again restore A by adding A equals to A plus B. And if it is 1, that signifies that A is greater than equals to B. So if A is greater than equals to B, then we again restore the number, but what we do, we shift it to the right side. So when we shift it, the exponent is incremented. By shifting this, we have ensured that the number is not greater than A and there will be no overflow. So overflow condition is not checked when we do the floating point number division, because we have already adjusted it. So now you see here what I am doing is that A equals to A plus B bar, small a. That small a represents that the output exponent we are calculating. So we want to subtract. So exponents are subtracted here and then bias is added. So in multiplication I have already told you what is bias. So bias is subtracted. So both the bias are cancelled. So we have again restored the bias. So A equals to A plus bias, and then this A is shifted to register Q's exponent part. So the exponent of quotient will go in Q, and then the divide operation of magnitudes take place, and how the magnitudes are divided, that we have already taken up in the fixed point number division. So this is how we can divide the floating point binary numbers. The end result will be stored in the register QR. So QR have two parts. One will keep the mantissa, capital Q, and small q, that will keep the exponent of the quotient. Where is the remainder? The remainder remains in register A. So this is how we can divide the floating point numbers. Thank you.